All right, let's see how it went, my friends. So first thing you want to do is just kind of look at the integrand and notice that it has a square root of the form a squared minus u squared, and don't worry too much about the rest of the stuff. So in this case, we would let u, which is x, equal a, which is 3 times sine theta. And then dx, my friends, would be 3 times cosine theta d theta. Okay, now from here, let's go ahead and just see what happens when we write this integral all in terms of theta. No more x's, just thetas. So for example, x squared right there, what would we swap out for that? We would swap out, we're just going to square both sides of that initial condition, or sorry, that primary relationship that is, and we would get, whoops, not x, goodness gracious, 9 sine squared theta. So that's what would replace x squared with. And then we'd have the square root of 9 minus, and again, 9 sine squared theta. And for dx, we'd replace that, my friends, with 3 times cosine theta d theta. All right. Well, it just looks like trigonometry threw up on this. But anyway, so let's go ahead and see, like what can we do from here? Simplifying that root, it's up to you how many steps you want to show. I don't show very many. In my head, I can factor the 9 out and know that 1 minus sine squared is cosine squared, and then I can square root it. And so for me, it makes sense that that entire radicand is equal to 3 times cosine theta. Okay, and it's up to you how many steps you want to show, or if you want to like kind of scratch that out on the side. The point is this: you had 9 sine squared theta already, and then that square root expression can be replaced with 3 cosine theta. And then you had 3 cosine theta d theta already off to the side that replaced dx. There we go. Okay, all right, now my favorite part with sound effects. All right, and so what are we left with here? Let's see, we're left with 1/9 times the integral of, what is that, 1 over sine squared? Ew, that's not what I wanted to have. Anyway, but, 1 over sine squared, that's cosecant squared. And is that horrible? Let's see. Is this a basic rule? What would we take the derivative of to get cosecant squared? Well, the derivative of cotangent is negative cosecant squared. So if we took the derivative of negative cotangent, we would totally get positive cosecant squared. There we go. All right, integral done. But why am I not totally finished? Well, because I was given a problem in terms of x, and I can't just give an answer in terms of theta. Like, that's just not right. So we're going to do what we did last time, but with a little bit of a twist. We're going to go back up to the primary relationship that we had between x and theta. I think I'm going to go ahead and maybe copy it over here. And like last time, I'm going to isolate the trig function, in this case by dividing both sides by 3. And I would know that sine of theta is equal to x over 3. Oops, that's so not a 3. My goodness. Okay. But last time it made sense to solve for theta and write arcsine and but this time, instead, you want to get the simplest answer possible. This time, instead, it makes a little more sense because you're not just asked what theta is, you want to know what the cotangent of theta is. It makes a little more sense to draw a right triangle and to label the x as opposite theta and the 3 as the hypotenuse for that triangle. And then you could use Pythagorean theorem to solve for the missing side length, and up to you how many steps you need to show. Okay, so now once you're there, you could figure out, well, if this is the relationship between x and theta, then what would the cotangent of theta be? Keep in mind that's just 1 over tangent, and tangent is opposite over adjacent, so cotangent would have to be adjacent over opposite. Hopefully that makes sense. All right, and now I'm going to use that to write my answer. Cotangent theta can be swapped out for the square root of 9 minus x squared over x. And so maybe I'll just write it a little cuter. There we go, my friends. All right. In the spirit of congratulating yourself for every point, please do give yourself some credit for every step that you got on your own, and give yourself credit for every step that actually now makes sense as well. Because if it makes sense, then it's yours. All right, my friends. Next example and a new tip. For integrals involving the square root of a squared plus u squared, again, where a is a constant and u is a function of x, you would let u equal, I wonder if you could guess this one, a times tangent theta. There we go. All right, other than having a different substitution to start out with, the procedure is exactly the same. So I'm going to butt out and let you do what you're going to do. See how far you can get. Check in with me in the next video.